spin around as fast as you can 3 times, and as the foot slams down, stop. Whoa, the room is still spinning. You planted your feet. You are clearly sitting completely still. So why does your brain feel like the world is still doing cartwheels? The answer is a tiny balance machine inside your head called the vestibular system. To see where that signal mismatch is actually coming from, we have to travel past the eardrum and straight to the source of the slosh. Deep inside your head, way past the parts that actually listen to sounds, sits a completely separate piece of machinery. These 3 tiny loop-shaped cubes make up your vestibular system. Inside those loops, they are filled with a liquid that sloshes around, like water in a half-empty bottle. Lining the walls of those fluid-filled tubes are thousands of microscopic hairs. Your ears are actually doing double duty. They process the sounds around you, and they actively work to keep you standing upright. Every time you stand on one foot or walk in a straight line without toppling over, your body is relying on that liquid and those tiny hairs to keep you steady. Whenever you move your head, the liquid inside those tubes sloshes against the sides. That liquid pushes on the tiny hairs, making them bend. When the hairs bend, they shoot a signal straight to your brain saying, "Hey, we are moving." But here is the trick. If you spin around really fast and suddenly slam on the brakes, the liquid doesn't stop. Thanks to momentum, it keeps swirling around inside your ear for a few seconds. Those hairs remain bent, continuing to scream to your brain that you are spinning wildly. But at the exact same moment, your open eyes are telling your brain that you are sitting perfectly still. Your brain suddenly becomes a panicked mailroom crook, trying to read 2 letters at once. One letter from your eye says, "We stopped." The other letter from your ear says, "We are doing a tornado." When your brain gets 2 completely contradictory messages at the exact same time, it creates a physical conflict. That specific sensory mismatch is the literal definition of dizziness. Fortunately, friction does its job. The fluid inside your ear eventually settles down, the tiny hairs stand back up, and your brain finally gets matching signals again. Because the system relies on gravity to know which way is down, astronauts often get extremely dizzy when they first arrive in space. Their inner ears have to relearn how to balance in a zero-gravity environment. Whether you are doing cartwheels in the backyard or floating through a space station, your internal physical structures are constantly calculating your movements to keep you safe. Challenge time. Question 1. What is the name of the balance system hidden inside your ear? The vestibular system. Question 2. What substance sloshes around inside those tubes when you move? Fluid. Question 3. Why does your brain get confused when you stop spinning? The fluid keeps moving. You absolutely crushed that. Smash the subscribe button to join our science crew. Power recap. The vestibular system controls your balance. The fluid in the tubes bends tiny hairs to send movement signals. And when you stop spinning, that fluid keeps moving, creating the sensory mismatch we call dizziness. Next time you spin around and feel wobbly, tell the adults around you that your ear fluid is just having a little trouble catching up. So now you know why we get dizzy. But what is the deal with that weird dot in the middle of your stomach? Why do we have belly buttons? Tap right here to find out.